evening. I am Barabasaurus, and this is Plastiki Rafiki News, bringing you the latest developments in grassroots ecological engineering. Our lead story tonight, the ongoing battle against low-value plastic waste has reached a significant student-led turning point. Globally, humanity purchases over 1 million PET bottles every single minute, yet fewer than 10% ever see a recycling facility. Tonight, we cross live to our field reporter Tumaini at the ISK lab to see what Hope and her team are engineering to solve this crisis. Tumaini, what do you have for us?
Thanks, Barabasaurus. I'm standing here at the lab next to what Hope and her team call their most valuable raw material, discarded PET plastic bottles. Now, for years, small-scale community recyclers have completely hit a wall with this material. While they can easily melt down HDPE milk jugs, such as those used by Plastiki Rafiki, PET has an incredibly sensitive, narrow melting window between 250 degrees Celsius and 280 degrees Celsius. Now, in standard extruders, such as the one being modified, it instantly degrades, releasing irritating fumes, or cools into a fragile, snapped plastic cord.
A formidable roadblock indeed. Tell me, Tumaini, how exactly are Hope and her team maneuvering around this structural challenge?
So from the information we're getting from the site right now, they aren't really trying to make solid plastic at all. Instead, Hope and her team are spinning it into soft, woolly, cotton candy-like insulation fibers. They pitched this incredibly creative concept to the Lions Tank funding competition and walked away with a massive $2,000 grant. Combine this with school support that from the Plastiki Rafiki Club, they have a total of a $2,300 budget to build Kenya's very first student-made Polyfloss machine. Isn't that exciting?
An exceptional achievement on the funding front, but let us dissect the science. Polyfloss sounds rather poetic, but how does the team prevent this molten polymer from becoming a sticky, unmanageable disaster?
It's all about moisture control and thermal zoning. As Hope explained to me, PET is highly hygroscopic, meaning it literally drinks invisible water right out of the air. If they don't bake and dehydrate their shredded flakes at 150 degrees Celsius for at least 4 hours first, the trapped moisture causes a destructive reaction called hydrolysis at high heat, which totally breaks the polymer chains within.
Ah yes, the classic wet flakes makes crumbly fibers dilemma. Fascinating. And once the raw materials are thoroughly dried, how does their machine process them?
So, the team's high-torque motor drives the flakes through 3 strict color-coded temperature zones on the barrel. First is the feed zone, which at 240 degrees Celsius softens the incoming plastic. Second is a compression zone at 255 degrees Celsius, which fully melts it down. And then at the metering zone, where at 265 degrees Celsius, it drops the viscosity so it can flow like honey through their custom end cap.
Intriguing. Now, our investigative desk has learned there was a significant pivot in the machine's architecture early on. Can you walk us through how they arrived at this current setup?
Absolutely. Originally, Hope and her team planned to build a spinning centrifugal head very similar to a commercial cotton candy machine like that one used by Polyfloss. But spinning a heavy metal cap at thousands of RPMs at 260 degrees Celsius was flagged as a major safety hazard for school environment. So, they pivoted to a much safer stationary nozzle combined with a high-velocity compressed air jet, which the school already has a portable one.
A prudent decision. Safety must always be the priority in engineering. How does this pneumatic system physically draw out those fibers?
So, they connect the standalone air compressor directly to their stationary nozzle using high flex lines. As the liquid plastic exits the die plate, a concentrated blast of high-velocity air shears and stretches the polymer into microfibers, which cools it instantly and shoots it out directly into the open-faced collection bin, such as that showcased in the simulation.
Every great scientific triumph is forged in struggle. Our sources on the ground indicate that Hope and her team faced some formidable scheduling roadblocks during her school hours. What can you tell us about that, Tumaini?
Oh, it was a real scheduling puzzle. So as Hope explained to me, her main STEM impact blocks fell right at the same time with a ceramics class happening nearby. Since melting recycled plastic at high temperature releases some pretty strong fumes, they couldn't run their hot extrusion test without disrupting the entire class process.
A minor diplomatic crisis on campus, it seems. How did they resolve it?
They adapted. Hope used her class time for more research, writing her custom WebGL simulation, evaluating the machine and its PID controller panels, which is basically the temperature controls, and understanding and designing the layouts for it. Hope and her team then ran all their high-temperature extrusion trials after hours, when the surrounding halls were completely empty. And during the weekends, Mr. Brown, one of the amazing design teachers guiding Hope through her project, searched for local Nairobi suppliers of heavy-duty stainless connectors to get everything built.
Truly remarkable resilience. As we conclude tonight's live report, Tumaini, what lies ahead on the horizon for this ambitious project?
Well, they're ready for takeoff. Next semester, they will bore the final micronozzles into the brass end caps, activate the compressor line to spin the first official batch of polyfloss, and measure the thermal R value of the fibers for community building insulation. How exciting!
Splendid work. Viewers wishing to explore this technology can visit Hope and her team's World Press site right now to play with the interactive 3D web simulation themselves. You can rotate, zoom, and inspect every component of the extruder line live. Tumaini, thank you for that spectacular report.
Anytime, Barabasaurus. Back to you in the studio.
And that is all for tonight's broadcast. A sincere thank you to Hope and her team at Plastiki Rafiki. I'm Barabasaurus, wishing you a pleasant, warm, and sustainable evening. Good night.